All right, we're moving on to lesson 5. Things start to get a little iffy here, but again, I'm going to use keywords that are really going to help you. So we're looking at 2 theorems today. One is called the remainder theorem, and one is called the factor theorem. Our essential question is, can you use the remainder and factor theorems to find factors of polynomials and to solve polynomial equations? So the remainder theorem tells us let p of x be a polynomial of positive degree n. Then for any number c, p of x is equal to q of x times x minus c plus pc, where q of x is a polynomial of degree n minus 1. That means nothing to us because it's very, very wordy. So let's take a look at example 1. They tell us exactly what to do. They're telling us to use synthetic division to find the value. So I'm going to give you a hint. The remainder theorem is when we use the remainder, where we use synthetic division, and the remainder is the answer. Now, the way we've always done this is in the past is we've put in -5 for this x right here. So we're literally putting in -5 cubed plus 2 times -5 squared minus -5 plus 4. And you can find the answer by doing that. But they're telling us to go ahead and try what we call synthetic division. So what I'm going to do is I'm going to show you how we use synthetic division. Let's see if I have a place to set this up. All right, I'm going to use -5 as my number right here. And my numbers across are 1, 2, -1, and 4. I did not need any zeros to fill in. And you know me, I always put a line and I make a little spot for my remainder. And remember, we said this remainder right here is going to be the answer. So this is what we're going to look at. The first thing I do is drop the 1. I multiply up 5 times 1. All right, when I multiply up, -5 times 1 is -5. Add down, I get -3. -5 times -3 is +15. Add down, I get 14. Well, I don't know what 14 times 5 is, so I'm going to find out very quickly. I get 70. So -5 times 14 is -70. And when I add down, the answer is -66. Now, if I was to put that in, just as we did down here with the -5s, we would get the exact same answer of -66. So the answer, using the remainder theorem, where the remainder is the answer, is -66. So all we did was plug in this -5 in synthetic division to find the answer of -66. The factor theorem is a little different. This one's just asking if something is a factor. So the factor theorem, the polynomial p of x has x minus r as a factor if and only if r is a root of the equation. So p of x is equal to 0. So remember that we know something's a factor if it divides through. So for example, the factors of 6 are 1 and 6 and 2 and 3. So they're asking, is this a factor? I can use synthetic division by putting in a +2 on example 2. And then I'm going to go ahead and use the 1, the -4, the 5, the 4, and the -1 to see if it's a factor. So 1, -4, 5, 4, -1. And if this remainder is a 0, so the factor theorem, we want the remainder to be a 0, then we know it's a factor. Add down. multiply up, add down, multiply up, add down, multiply up, add down, multiply up, and add down. This would have had to be an 11. I actually wonder if that was an 11. It looks like it got cut off, and I don't have my actual notes on me. But in this case, if that was a 1, this is not a factor. I know it would be a factor if the remainder ends up being 0. So for both the factor theorem and the remainder theorem, we need to look at the remainder. The factor theorem, it is a factor if the remainder is 0. The remainder theorem, the remainder is the answer. All right, so I'm going to do one more. I'm going to use the factor theorem to see if b minus 4, that binomial, is a factor of b cubed minus 5b squared minus 2b minus 8. So the first thing I'm going to do is put a 4. Remember, we always take the opposite of the binomial. And then I'm going to take the numbers 1, negative 5, negative 2, and negative 8. And remember, we want this to be a 0. If it's not a 0, it is not a factor. Add down, multiply up, add down, multiply up, add down, multiply up, and this is not a factor because it will not be a 0. It will actually be a negative 32.